Welcome to Kojo's Math. How are you doing tonight? You ready for this? Well, I hope you will. Well, I don't know what time of day it is for you. Today we're going to be talking, tonight, this morning, whatever. Our lesson today is going to cover adding and subtracting fractions with unlike denominators. Now this should be a review for you, but we're going to go over it just a little bit before we get into the variables. When we add fractions with unlike denominators, people want to go 3 times 12 is 36, and 36 is the common denominator, and then they want to convert 3 goes into 36 12 times, and 12 times 2 is 24, and 12 goes into 36 3 times, and 3 times 5 is 15, and then add them and then simplify. But you're going to have to deal with larger numbers when you do something like that. So we don't want to do that. What we want to do is get the least common multiple of the two numbers. Instead of just multiplying these two numbers together, we want to get the least common multiple. It's going to save us work later. So the least common multiple of these two is 12 instead of 36. So when we convert that, we're going to make it the common denominator is 12, and then we're going to say 3 goes into 12 4 times, and 4 times 2 is 8. And because this one stayed the same and 12 is the common denominator, we're just going to bring down the 5. Oh boy, I think I need a new marker. So 8 plus 5 is 13. So the answer is 13 twelfths. You can leave it like that as long as it's in lowest terms, or rewrite it as 1 and 1/12. I prefer these, especially when we get to the variables. I don't want you to try to write them in mixed fraction form. I want the variable ones to be left as what you might see or term as improper fractions. You really don't know because you know what the variable represents. On this one, watch what happens. So we're going to be subtracting, so we're going to have a negative number. Let's get a better marker that works. Let's use red. So I'm going to go ahead and convert this into improper fractions. So I get 6, I get 7 halves, just because I like working with improper fractions. We talked a little bit about it in class, how we could borrow and whatnot, but I like working with improper fractions. And this becomes 19 fourths. Okay, so what we're going to do, 4 times 4 is 16 plus 3 is 19 fourths, 3 times 2 is 6 plus 1 is 7 halves. Common denominator, we could go 2 times 4 is 8. We don't want to do that because it's going to create more work on the other end and cost us more time. It's better to think smarter, and then instead of having to do more work later where there's greater room for error. So we're going to get common denominator is 4, 2 goes into 4. That's right, 2 times, and 2 times 7 is 14. Then we have 19 fourths. 14 minus 19 is negative 5 fourths. Again, I want you to leave it as an improper fraction for these. All right, so that was just a quick little review for adding and subtracting fractions with unlike denominators. So now let's look at variables. When we have variables, we don't know what the variables represent. We don't know what numbers they are. But we know that here we're going to say, well, what's the least common multiple of x and y? Well, since we don't have the luxury, like we had here, of saying, well, we don't want to go 3 times 12 and get 36. We want to say, well, what's the least common multiple? 12 is. But when we have variables, we don't have that luxury of knowing what does x and y stand for. But we know that we can multiply them together. Do you see how that works? So here we're going to say the least common multiple that both denominators go into is x and y, because I would multiply x times y. So I'm going to make 2 fractions with the new denominator. Now remember, when we did this, and we're going to convert 2/3 into 8/12. We looked at the denominator, and we went, and maybe if we look at it this way, and we said, all right, 2/3 equals how many 12s? 3 goes into 12 4 times, and 4 times 2 is 8. So that's how we got 8/12, right? Well, same idea, but we're going to be working with variables. Same idea, but we're working with variables. So we're going to go, we'll come over here so you can see it, and we'll say, okay, 3 over x equals x over 1 over xy. So we treat x as a factor. The factor of whatever the product of x, y is. the product of xy has two factors, x and y. So if x goes into xy, what's left over? Y. So you say x goes into x and y, we use the x with y left over, so it's 3 times y, y times 3, which becomes 3y. So the same thing, y goes into xy with what factor left over? X, and then x times 5 is 5x. You cannot leave it like this. You cannot leave it as 3y plus 5x over, or 3y over xy plus 5x over xy, because you have the knowledge and the ability to take it one more step. This is still two fractions. You've got a common denominator, so you can add them. So what we can do is say, and we can put this, if you don't put it in alphabetical order, it doesn't bother me this time. But we could say 3y plus 5x over xy. That is a fraction. We took two fractions and add them together, and we've created one fraction. The problem is we don't know what all the variables are, but that's okay. So we leave it as 3y plus 5x over x times y, or xy. Or we could rewrite it as 5x plus 3y over xy. We cannot cancel the x and the y here. Very tricky. This x, this xy goes with both of these terms, 3y and 5x. In order to cancel the x from the denominator, you have to have an x in every piece, every term of the numerator. That's like saying that if I had a 2 here, the 2 would be here, but there's no 2 here. That's not a 2. We don't know what y is, but we have to assume it's not a 2 because it's a different variable. So let me say that again. This is a product, two factors xy. But up here, this is 3y plus 5x. The x is only with the 5. It's not with the 3y. And the y is only with the 3y. So you can't cancel these x's or the y's. This is your final answer. That's as far as you can go. Now this one. What's the common denominator? Well, here we have coefficient 5 and coefficient of 3. If they were coefficients like this, where it was 3 and 12, right? And we said, okay, 12, or where it was, where we could create it with the coefficients, we would use this, we're going to use that format with the numbers of the coefficients, okay? But this one, what is the least common multiple of 3 and 5? 15. So we're going to convert each of these fractions into 15xy. Both the variables have to be in the new denominator in order to convert it over to the other side. So I say 15xy and 15xy, so now I'm going to convert it. So I say, okay, 5 goes into 15, how many, with what left over? 3. We're just doing a conversion of a fraction. So 5 goes into 15 3 times, and 3 times 4x is 12x. We multiply the coefficients. When we come over here, we go 3 goes into 15 how many times? I forgot something, didn't I? Yes, I did. 5y goes into this with 15x left over. Oh, I almost caught. I was trying to do it piece by piece, so you got to be careful. Let me do that again. Let's watch this. Okay, made a mistake. I caught myself. Okay, so I say 5y goes into 15xy with what left over? 5 goes into 15 3 times. So 3 times 4 is 12. Y goes into xy with what left over? What am I multiplying y by to get xy? X. So x times 4, x times x. Because I'm bringing that up. Remember 2 x's? We did that last week, is x squared. 2 x's is x squared. Now I go over here and say 3x goes into 15xy with what left over? Well, 3 goes into 15 5 times, and 5 times 1 is 5. And then x goes into xy with what left over? What do I multiply x by to get xy? Y. So x goes into that, what, y left over, so y times 1 is y. Now we can't leave it like this because it's 12x squared over 15xy plus 5y over 15xy. We're going to write this up. We can write this over one fraction, which is 15xy. But the numerator, we can't add these. They're not alike. We don't know what x is, so therefore we don't know what x squared would be to multiply it by 12. We don't know what y is that we could multiply by 5. We don't know that. So we have to bring those down. These are expressions. They're not equations. So it becomes 12x squared plus 5y. That's all we can do. Now, but look at this. We look at the coefficients, 15, 12, and 5. Is there a number that goes into all three? Like 5 goes into 15, but 5 doesn't go into 12. The coefficients to cancel or to simplify, there has to be a factor in all three, not just 2. So I can't simplify. I can't cancel the 5 here and the 3 here because it has to be a factor of all three terms. So now I look at x squared and y and xy. Same problem. This term, 12x squared, only has an x squared. This has an xy. But this term only has a y. It doesn't have an x, so I can't cancel anything. This is my final answer. I can't do anything else because I don't have enough information. Okay? It's a little tough. You can do this. So now I want you to try these. These are just simplifying. 4a over 6b, 5w over 3w squared, 4 over a plus 2 over b, 5, 6 divided by -10. Do you remember what this is called? What's it called? Compound fraction. Then you have 2 over vw minus 1 over v, and 6x over 3y plus 2/4. Pause the video, do these problems. Start the video when you're ready to check your work. Welcome back. Let's see how you did. On the first one, you should have gotten 2a over 3b. On 5, 6, the compound fraction, you say 5, 6 divided by -10. You change it to multiplication, take the reciprocal of the second number, so you get 5, 6 times -110, which simplifies to -112. Then I have 5w over 3w squared. That simplifies to 5 over 3w. Now here's the tricky part. The common denominator for a and b is ab. When I converted it, I get 4b over ab plus 2a over ab. I get 4b plus 2a over ab. I cannot cancel because I have to have an a or a b or something in every single term. Or you can put 2a over 4b equals ab. And the last one, I put on a separate paper, a separate board. Let's look at this one. Common denominator was 12y. When I converted 6x over 3y into the new one, I got 24x over 12y. Because 3 goes into 12 4 times, and 4 times 6 is 24. Okay? I looked at these two, and there's only one variable I have to have, and that's a y. So I come over here and I say 4 goes into 12, 3y times, there's a y here that this doesn't have. So 3y times 2, and I didn't write it down, is 6y. So 4 goes into 12y's, and 3y times 2 is 6y. Fix that. Now, notice what happens. I'm going to write 24x plus 6y over 12y. Now watch. What's unique about this? There's a y in the denominator. There's a y with the 6y, but there's no y with the 24x. So we can't do anything there. However, look at this. 24, 6, and 12 all have what common factor? 6. See, all three of them have it. So I can simplify that fraction because I can divide 24 by 6 and get 4x. 6y divided by 6 is y, 1y, that's a y. And 12y divided by 6 is 2y. So the final answer is 4x plus y over 2y. Got it? All right. It's a little confusing, but if you just stop and think about it, you'll do great. All right? Here's what I want you to have. This is your ticket into my class tomorrow. When you walk in tomorrow, I want to see 2 things that you learned and 1 question that you still have. I got to see it for you to walk into my class. If you don't have it, you can't come into my class until you do. All right? I'll see you tomorrow. You have a great time or a great evening.